My name is Natalie Camille Tilley, and this is my MATLAB project. This is the first question of our project. My project begins with outputting print statements and asking for user input for them to select which signal they want to use. I have a series of if statements to sort the user's input. So if they did select signal 1, the signal parameters are hard-coded in, and then the code moves on to solving the Fourier series coefficient, x of n. I use the eval function to solve the 1 over the period times the integral function of x, which is the signal, times exponential of negative j n omega naught t. This is an integral taken with respect to t from the lower bound to the upper bound. Once x of n is calculated, it prints a heading statement, and then it enters a loop from 1 to the length of x of n, so for every coefficient value, and then it will outprint it in the format of x of n is equal to the coefficient value. This is the following if statement, else if signal equals 2. So if the user selected signal 2, again, its parameters are preset, but they are different from signal 1's. And the math for calculating the Fourier series coefficient is the exact same, along with the output statements to print it to the user. Else if signal equals 3, this is for if the user selected an arbitrary signal, so the preset values do not exist, and so it actually prompts the user to input their signal, the signal's period, and then the upper and lower bounds. Again, after that, the math and output statements are done the exact same way as the other two. But then you'll finally see my if statements. They close with an else statement that says unknown signal number entered. So if a user does not enter 1, 2, or 3, it will output this error message. Now we're going to plot our data. So we're going to plot the magnitude spectrum on figure 1, the grid is on. We're going to subplot it in location 2, 1, 1, and we're going to use the stem function because we do not want a continuous line. Our x-axis is going to represent the n values, and our y-axis is going to be the absolute value of our Fourier series coefficients. And then I added a detail of making sure that this plot was done in red. And then I do label my graph and axes. Looking at the phase spectrum, I also want this on figure 1, and so that's why I use the subplot function to move this graph beneath the magnitude one. And then I use a stem function again, and my x-axis values are n times omega naught divided by 2 pi, and my y values are the angle of the Fourier series coefficient, but then I multiply it by 180 over pi, and that is to change it from radians to degrees, since MATLAB initially does everything in radians, and I want my graph in degrees. And I made sure to make this plot blue. And then again, I did label my graph and axes. So now we're going to solve the actual Fourier series. We're given 3 separate ranges of n values, but then on our actual plots, we want to make sure we show more than just one period of these values. So we're going to multiply our period times 3, and so our t is going to go from 0 to 3 times our period. We want these graphs on figure 2. And then for each iteration of the n ranges, we're going to create a Fourier series vector that is first full of zeros, and then we're going to determine our upper and lower bounds of n and declare that range. Then from 1 till the entire length of t, so 3 times the period is the length of that, we're going to solve the actual Fourier series value, and that is going to call our x of n value that we have previously solved. After that, we're then going to use the subplot function to call each range value and plot that, again on figure 2. And I do have a dynamic title that should label it with the graph title and then the n value range beside it. Here are my graphs of signal 1, so you can see my magnitude, phase, spectrums, and then on figure 2 I have my Fourier series with the 3 different ranges of n values. Here is a screenshot of the user prompts and then also the x of n values printing out just for visual representation. You can see the user being asked which signal options they have and then selecting their signal, what they did indeed select, and then calculating their x of n values. Here's a quick overview of my signal 2 output. Here is my output of an arbitrary signal I entered. This is our question 2. My function begins by asking for user input and then storing the signal in x. We want to transform lowercase x of t into caps of f, so by doing that we are going to integrate our signal x times the exponent of negative j 2 pi ft with respect to t from 0 to infinity. Now we have caps f. We want to take the magnitude of that and square it, so lines 29 through 31 do that, and that is equal to caps g of f. Following this, we want to solve total energy, which is ET, and so I set that equal to the evaluation of the integral of g of f with respect to f from 0 to infinity. After that, we want to solve w. That is the goal of this project for question 2, and so I create a variable solution, and I set that equal to the solve function of 0.95 times ET. That is because we want 95% of the total energy that we just solved above, so we want 95% of the total energy set equal to the integral of caps gf with respect to f from 0 to w. And again, we're solving for that w and storing it in the variable solution. Line 38 creates a double that assigns the type of variable we have into the form of a double, and then I have a print statement where it says the value of w is %f, and then calling the solution to be placed into that. These are my signal outputs, so I asked output signal 1, and so my w value is 4.04, and then I put 3 in, and just for robustness, it says invalid option entered. So that was my MATLAB project. For each question, I started out by solving it by hand, mathematically, just to be sure I understood the steps, and then translated that into MATLAB code. I think that process worked pretty well, and I hope you enjoy my project.